Welcome to doassignment-ca. Here is the problem. A 10-kilogram block rests on a smooth surface and is subjected to a horizontal force of 6 newtons. Observer A is in a fixed frame X. The block has an initial speed of 5 meters per second and travels 10 meters, both directed to the right and measured from the fixed frame. Observer B moves at a constant velocity of 2 meters per second to the right relative to A, attached to the x-prime axis. Part 1. Using the principle of work and energy, determine the final speed of the block as measured by observer A. Part 2. Repeat using observer B's frame and show that both observers obtain the same final speed for the block relative to their own frame, shifted by 2 meters per second, thereby demonstrating that the work-energy principle is valid in any inertial reference frame. Now, let us work through the solution step by step. In observer A's fixed frame, the block starts at 5 meters per second and moves 10 meters under a 6 Newton force. Plugging into the work-energy equation, 1/2 times 10 times 5 squared plus 6 times 10 equals 1/2 times 10 times v2 squared. That gives 125 plus 60 equals 5 v2 squared, so v2 squared equals 185 divided by 5, which is 37. And the final speed is the square root of 37, which is about 6.08 meters per second to the right. Observer B moves at 2 meters per second to the right, so to convert any speed from A's frame to B's frame, we subtract 2 meters per second. The block's initial speed seen by B is 5 minus 2, which is 3 meters per second. The final speed seen by B will be root 37 minus 2 meters per second. To find the displacement in B's frame, we first need the elapsed time. The block's acceleration is 6 divided by 10, giving 0.6 meters per second squared. Using the kinematic equation in A's frame, 10 equals 5t plus 0.3t squared, which rearranges to 0.3t squared plus 5t minus 10 equals 0. Applying the quadratic formula gives t equals -5 plus or minus the square root of 5 squared minus 4 times 0.3 times -10, all divided by 2 times 0.3. That simplifies to -5 plus or minus the square root of 37, all divided by 0.6. Taking the positive root gives approximately 1.846 seconds. Observer B moves 2 times 1.846, which is about 3.61 meters in that same time. So the block's displacement as seen by B is 10 minus 3.61, giving about 6.39 meters. We can verify this using the relative initial velocity of 3 meters per second and the same acceleration, which also yields 6.39 meters. In observer B's frame, the initial kinetic energy uses the relative speed of 3 meters per second, and the work uses the relative displacement of 6.39 meters. 1/2 times 10 times 3 squared plus 6 times 6.39 equals 1/2 times 10 times v2 prime squared. This gives 45 plus 38.34 equals 5 v2 prime squared, so v2 prime squared equals 83.344 divided by 5, which is 16.669, and v2 prime is approximately 4.083 meters per second. Adding B's velocity of 2 meters per second back to the 4.083 meters per second gives 6.083 meters per second, which is exactly root 37, matching observer A's result perfectly. This confirms the principle. As long as each observer uses speeds and displacements measured in their own inertial frame, the work-energy theorem gives correct and consistent answers in every inertial reference frame. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.